and fairness in AI are two sides of the same coin, and they are inevitable to face within AI systems because our words will with bias. Our modeling methods can introduce bias even if we have perfect data. Therefore, AI applications suffer from injustice to individuals due to their gender, race, and sexual orientation, and so on and so forth. Up to now, most work in the deep learning area has been based on gender bias, whereas there are in total 3 papers on machine learning and no paper research deep models for racial bias. In this work, we are focused on the mitigation of human-like biases and undesired social stereotypes in the BERT model. And explain a living example from one paper. This task is a simple NLP task for masked language models. We are given a sentence with one missing word and we expect our language model to predict the unknown word. In this case, our language model is BERT and the sentence is of the form the V is a mask where V is one of man, woman, black man, white woman, white man, and the mask is the word to be inferred by BERT. We notice that the genius has the highest probability when V is man and it doesn't appear anywhere else. Conversely, lesbian is one of the most five likely words for black woman. Furthermore, other possible words for black woman are slave, witch, and prostitute.
We developed a web platform to visualize bias in language models. We can select from drop-downs to which model to use and in which word group to detect bias. We developed a bias score comparison of models based on presenting ratio. Here, we see that all models assign nurse, hairdresser, and homemaker professions to women.
On our web platform, we can also visualize word embeddings after applying the PCA algorithm to reduce their dimensions. Our aim is to discover biases in different language models to answer which model we work on and for what we debias our model.
Auto-Debias model follows an adversarial approach. In case of gender, target words are male and female-related words, and attribute words are stereotype words. At first step, the goal is to find a prompt that maximizes divergence of probability that the mask is predicted as stereotype word by the model. After prompts are generated with this structure, we penalize the language model with Jensen-Shannon divergence of these probabilities. We adapt this structure to an intersectionality approach. Instead of female and male-related word groups, we use black female and white female-related word groups, so that we can equalize the behavior of model to intersections of genders and races.
After completing our second phase of training, we compare the word embeddings of the original word and our model. It can be seen here that lots of respective proficiencies are needed to the man to the original word. Since the Euclidean distance between word embeddings of a man and woman is decreased after debiasing, professions have almost the same distance to each gender for our model.
We compare our model with BERT and Auto-Debias that debiases BERT toward genders. Seed 6, 7, 8 are gender tests, and Seed Angry Black Woman, which we denote as Seed ABW, evaluates bias towards black females and white females. Most of the scores of our method is better than Auto-Debias. We see that even if we debias toward intersectionality, it also improves the gender scores.
In conclusion, we visualized word embeddings of word-to-vec, GPT, and BERT to find likely points of improvement. Bias is measured by cosine similarity of word embeddings. The most probable words are punctuation, pronouns, and prepositions for film masks, despite good C-scores. Most work focuses on gender bias, and these words are mostly on binary level and include only professions.
We can calculate distances of even more than 2 terms by just divergence, so that the Auto-Debias approach can be easily extended to multiple classes. Hence, we can take into account also other intersections. And in prompt generation, instead of considering most used words in Wikipedia, it may be better to select from the sentences that contain profession to get more meaningful sequences.